guys, thanks for coming. So I'm just going to try to go through these slides quickly so we can get started. We're already a little bit late. This is our meetup. If you want to know more, go to our website, soulbitcoin.kr. We don't do any altcoin investing stuff, only Bitcoin. So I'm going to go through kind of like what Bitcoin is really quick, really shortly, and then transition to Lightning and just kind of explain what the point is of us using the Lightning Network today. And then I'll go into the API stuff that we're going to be using in order to make apps easily. Here, I'll show this link again at the end, but all the links that I show will be in this Google Doc. So you can just go there, you can get all the information. So what's Bitcoin? Really, it's just a list of transactions that anyone can add new transactions to. And everybody can verify. And that's really the main important thing about Bitcoin. It's this big open list of transactions, and anybody can participate in it, and that makes it a cryptocurrency. So, when I say anyone can add transactions, it's basically the miners that are adding these transactions. But anyone can be a miner, ideally. It's a little bit difficult, it's a specialized job, but theoretically you can be a miner too. Or you just pay a transaction fee to another miner, and that miner will process your transaction for you. And everybody can and should verify everything, meaning miners can't cheat. If they put in a transaction that's not true, that's not valid, everybody would notice. And this is terrible for scaling. This is why blockchains don't scale, because everybody verifies everything. Imagine I send a transaction to Ben. That transaction goes to everybody. Everybody verifies it. And even if a new person comes into the network in the future, even they will verify my past transaction with Ben. So you can kind of imagine why it doesn't scale. Everybody verifies it. Okay, so, well, you know, why does this all matter? Why do we even want Bitcoin? Why don't we just use fiat then? Well, what it enables is a new type of money, and I think it's important to kind of outline the benefits, because this also kind of flows into Lightning and why Lightning matters. So one of them is the fixed supply, right? So we have 21 million coins, no more. I think most people in this room notice. And I think this is really the important one, permissionless use of the network, right? If anybody can send a transaction and anybody can verify it and check it, that means you essentially have this network without permission, right? If you want to receive some Bitcoins in your app or anywhere, nobody can stop you, and you can just do it. And this is also digital settlement. If you think about it, like normally we use IOUs. We have a digital payment. If I send money from my bank account to your bank account, that money is still like the physical money. Like you still have to go to the bank and get like a fiat note in order to really redeem that money, and the bank might say no. Right? So you don't have this settlement idea. But with Bitcoin, if I send you some Bitcoins, it's settled. Right? You have it, and nobody else can take it away from you anymore. That's not the case with using banks. So this is kind of cool, right? We've got this like new type of money that Bitcoin enables, but it doesn't scale. So that kind of sucks. So the downsides of Bitcoin are no scaling means transactions will be costly in the future. Even if it's cheap today, you can send a transaction for a couple cents. That does not necessarily hold up in the future, and I think that will go away. And confirming transactions takes time. That's just how we make sure everybody gets everything. Your transaction needs to go over the entire network. Everybody needs to have seen it, and everybody needs to come to consensus that your transaction is valid. So that, again, takes a long time, which is maybe 10 minutes, maybe more, depending on lots of factors. So this kind of means that microtransactions are impossible, right? Like, it's expensive, it's got to be expensive at least, and it's going to be kind of slow. Like, I send you 1 cent, and then we wait 10 minutes. That's not a great microtransaction. So maybe we can do something else, right? Maybe there's a possibility, and that possibility is Lightning. So in a nutshell, really short, kind of what Lightning does is, really what we're doing is we are opening up a channel with a person that we want to pay. So let's say I want to send some money to Ben. I know I'm going to send a bunch of transactions to him. So I lock up money with him. And now we kind of make these off-chain, so not on the Bitcoin blockchain, but off-chain digital promises, where I say like, well, out of these 5 Bitcoins that I locked up, I'll send you 1. So I will have 4 Bitcoins, and you had 5 Bitcoins earlier, now you have 6 Bitcoins. And these promises are kept between us, so we don't really send them to anyone. And then if there's ever a dispute, if Ben ever goes and says like, well, I'll just take all the Bitcoins that we have in our channel, then the Bitcoin network can get to verify the evidence. I can submit my evidence and say like, no, Ben agreed that I only sent 1 Bitcoin to him, so he should have 6 Bitcoins, not 10. And the blockchain will always rule in your favor because the evidence will always be correct, assuming you can actually present your evidence to the blockchain. So again, I'll go through this really quick. So normally with a Bitcoin transaction, Alice has 1 Bitcoin, sends it to Bob, and then as soon as that transaction gets to the Bitcoin blockchain, Alice's 1 Bitcoin is now spent, right? It's no longer usable. So instead, what we have here, what I was saying earlier, is just Alice and Bob, or me and Ben, both putting 5 Bitcoins in the channel. So there are 10 Bitcoins in this transaction, so to speak. And if you want to spend those 10 Bitcoins, Alice and Bob both have to agree. So they create a transaction where they say, okay, well, this transaction says Alice gets 4 coins and Bob gets 6 coins. So from 5 and 5, they went to 4 and 6. So that means that now, basically, Alice sent 1 coin to Bob. However, this transaction, they do not send to the blockchain. They'll just keep it because maybe Alice wants to send another Bitcoin. So they update it. So now it's 3 and 7, right? And Bob holds on to this transaction, and at any time, Bob can send it to the blockchain and get those 7 coins, but he still waits. He gets another transaction, 2 and 8. Okay, great. So maybe now they're done trading, and Bob sends his transaction to the Bitcoin network. Now Bob has 8 Bitcoins, Alice has 2 Bitcoins, and even though 3 transactions occurred, only 1 transaction gets recorded onto the Bitcoin blockchain. So, and you can do the same thing with right? You can even go back and forth, but that gets a little bit more complicated, so I'm skipping over that. So, okay, this is 2 people, right? This is Alice and Bob, but you can actually create chains of payments. So if Bob also has a channel with Carol, Carol also has a channel with Dave, now we can do something like this, where Alice gives a Bitcoin to Bob, provided that Bob gives a Bitcoin to C, provided that C gives a Bitcoin to D. And now Alice is essentially paid Dave. So looking at this more clearly, we can see, Alice had 5 coins, now Alice has 4 coins, Dave had 5 coins, now Dave has 6 coins. And Bob and Carol being in the middle, they still have 10 coins, right? 5 equals 10, 6 4 equals 10, and the same here. So Bob and Carol didn't lose anything, and Alice was able to transfer 1 coin to Dave. And that's really how the Lightning Network works. So anyway, long story short, what happens is cheap, trustless transactions. Why is it cheap? Well, because in this transaction, this example, Alice, Bob, Carol, Dave, only those 4 people are communicating with each other. Right? Only those 4 people were sending messages and trading basically Bitcoin transactions that didn't go to the Bitcoin blockchain. And because of that, it doesn't involve everybody. Not everybody has to verify all those transactions. It's just the 4 of them. They just verify each other's transactions, and that's the end of it. So that makes it much more scalable. Confirmation is near instant because all it requires is all the evidence. As soon as Ben gives me a signature, that means the transaction can be sent to the Bitcoin blockchain at any time, and I'm in no rush to do so. So really, that means I know for a fact that Ben has paid me as soon as I get a signature, and that makes it instant from my perspective. The downsides, though, are this is incredibly complex when you actually look into it. You have all these channels with all these amounts, and you have to figure out a route from one person to one person to one person to pay somebody. That creates a whole new mess of computer science problems that anybody can try to solve, but it's not very easy. The ideal way you do this is you install a Bitcoin, right? You install a Bitcoin full node, and you wait half a day or so to verify the entire blockchain, make sure every transaction since the beginning is correct. Then you install the Lightning Network, some Lightning Node, their different implementations. And then you keep this running 24/7, and you utilize this to kind of keep track of your channel. And really, any payment in the Bitcoin, in Lightning specifically, is interactive. So you've got to be online to receive the payment, to send the payments. So you can use a Raspberry Pi or something, and just have it in the corner of your room. Great. So this is how you do it if you want to be trustless. You don't want to depend on anybody, and nobody can prevent you from utilizing the Lightning Network if you do it this way. However, we're here at a hackathon, and we don't really have time to wait half a day, install all these still rather complicated apps, because obviously it's still new technology, so it's not super easy to use. So we're going to do it the easy way, but centralized. So please, if you actually are going to release your app in the future, do not use this. But for now, we're going to go this way. So really short, and you'll get this later in the document that I'll share with you. You just sign up at this website, dev.opennode.co, and you get a testnet account basically. You go to settings, API keys, add key. So you add a key there. You create a key for withdrawals, which gives you just access to everything. So you can send and receive Lightning transactions with this API key. If you're going to use mainnet, so not testnet, this is not secure, right? If anybody gets your API key, they can take all your money. So just be aware. But for now, for just making sure everything works, use this key. And then you can click API documentation, and you'll get all the information as to how to connect to the API. So this will be for the people that actually program in the room. I'll just very quickly kind of give you a brief summary of what the important parts of that API are, so you don't have to waste too much time figuring out everything. So on the API page, on the API documentation page. The way you generate an address for the Lightning Network it's called generate a charge. And it's a post request, and you send some JSON in the body, and you authorize with your API key. So in the body, you just give it the amounts, like how much you want to charge somebody, how much money you want to receive, and the currency you want to receive it in. So it'll convert it into Bitcoin automatically. You can also do BTC. I believe it does Satoshi stand. So one BTC would be one Satoshi, not one Bitcoin. That might be a little confusing. It will return an ID, so this is a unique identifier for your transaction, and this Lightning invoice.payment request, that is going to be the actual Lightning address that somebody can use to pay. So the next thing you want to do is know when somebody actually paid you, right? So that is charge info. So this is a GET request, and you have to authorize yourself again. So you call it on the ID that you want to check. So you received an ID here, then you check the ID here, and it return a status update, right? It will return whether the status is paid now or whether it's still unpaid. If it's paid, it means you received your points. So really, that's all there is to it. I created a very short demo of this on my GitHub account, so you can check it out there and just read these 50 lines of code to kind of understand how that works. And the second thing is how do you actually pay, right? Like we want to pay each other eventually with these Lightning transactions. So we created the transaction, but how do we pay the transaction? So you can also use the API for that, but for easy testing, go to hdlc.me. It's a super easy testnet wallet. Again, it's centralized, but it doesn't matter. It's testnet. We're testing it out, and you can just paste a Lightning address in there and just pay it just like that. All right. So optionally, so you don't have to do this for the hackathon. Receiving money is enough, but if you also want to do other things, so the first thing is there's support for webhooks. So if you want to actually scale your application, you can't just pull the API and ask, has it been paid yet, has it been paid yet, has it been paid yet. You want to use a webhook. So you'll receive a notification saying like, oh yeah, your payment is paid. So again, we don't need to do that for this. Hackathon is good to know. And initiate withdrawal will allow you to actually send coin. Bitcoins, right? What we did earlier is only receiving Bitcoins on the Lightning Network. And that's enough for an app, right? You want to get paid, you don't want to pay your users, but maybe you do. You know, maybe you have a more interesting app. That does make things more complicated, but it's possible. Because now you require your user to give you an address if you want to pay them. So it's a bit of a hassle, but definitely doable, and definitely opens up more possibilities for the apps. And finally, you can switch over to mainnet and actually, get real Bitcoins. But I gotta warn you, this is absolutely reckless. If you mess up, you might lose money, your users might lose money, so be careful. Don't be reckless, or do. Alright, so to get started, we're just gonna build fun microtransaction apps. We're gonna split up in teams of 4. We've already kind of done that, but maybe we're gonna switch it around a little bit to make teams more even with programmers and non-programmers. And you're gonna brainstorm. Try to think of like fun things you can do with like what if it was super easy to receive small amounts of payments really quickly, really fast, really often from lots of users. What kind of apps could we build? That's kind of the mindset you're gonna take, and then actually try to build it, and then present it at around 4:30 p.m. Everybody gets around 10 minutes to present, so short presentations. And it's okay if the app doesn't fully work, or if it's buggy, or if you got halfway there. You can just present the idea, and that's also what people who do not know how to program, they can work on the presentation. So finally, we've got some cool stickers. They're over there. There are actually more stickers than in the pictures here. We got some of our own stickers like this one. So these were provided by Blockstream, so thanks to them. These are cool Lightning stickers, so you can actually show off that you've been working on Lightning. And we got hats. So everybody here receives one of these very awesome, cool, reckless hats. Again, thanks to Blockstream and Samson Mo. So thanks for them. Here are the links. Check it out. You can find all the information I talked about here. And let's get started. Thanks. So the groups are going to have to change a little bit. Like we got no